Okie dokie, this is part 3 of the Math 1014 Exam 1 review. In this video, we will be simplifying rational expressions, and we will be simplifying also rational expressions, but with multiplication and division, and then I think that'll be it. All right, let's get started. We are looking at number 1. In order to simplify something like this, where we just have a bunch of factors divided by one another, we just want to find factors on top and bottom that match and get rid of them, cancel them out. X plus 5, 3x minus 2, 3x minus 2. What are we left with? X minus 4 over 4, and that's it. Something to point out is they say be certain to identify any restrictions. So I think what they mean by that is from the start, there might have been some x values that would have caused some problems. In other words, would have made the denominator equal to 0, making the entire value undefined. So I think we have to draw attention to those. If we want to find the x values that would have made the denominator equal to 0, we're going to set the factors equal to 0. So x plus 5 equals 0, and then solve for x. So x equals negative 5 would have been an x value that, when plugged in, would have made this equal to 0, which would have made the whole denominator equal to 0, which would have made the whole rational expression undefined. So I think in terms of restrictions, technically what we should say is x cannot equal negative 5, because if it does equal negative 5, we have an undefined value. So we do the same thing with the 3x minus 2 that was also in the denominator. Set it equal to 0, solve for x, you end up getting 2 over 3. Again, x cannot equal 2 over 3. Again, we only set these equal to 0 because they were in the denominator. It's not just because they were the ones that canceled out. We set them equal to 0 because they were in the denominator and would cause the denominator to be equal to 0, therefore the whole value undefined. Let's do the next one. Notice they don't give us the factors. We have to find the factors here. So we're going to factor the numerator and denominator with our skills. Up top, we need two numbers multiplying to negative 3 but adding to negative 2. So minus 3 plus 1. On bottom, multiplying to negative 4 but adding to negative 3. So x minus 4, x plus 1. Now we can simplify. Plus 1's cancel, and we're left with just x minus 3 over x minus 4. So that is our simplified answer. Again, we need to set the denominator factors equal to 0 so that we can claim that x cannot equal 4. Likewise, x plus 1 equal to 0, so x cannot equal negative 1. Again, x cannot equal these because they will make the denominator equal to 0 and make the whole thing undefined. That's why they are restrictions to this simplified expression. Okay? Number 3, we need to factor as well. Notice we can pull out a GCF on top and bottom. That GCF would be 2. So we have x squared plus 2x minus 3. 2 again, x squared minus 3x plus 2. And we can go ahead and get rid of those 2's, and now we just factor the numerator and denominator. So two numbers that multiply to negative 3 but add to 2, we're looking at x plus 3, x minus 1 on bottom. Multiplying to 2, adding to negative 3, we're looking at x minus a 2, x minus a 1. We cancel the x minus 1's, and we're left with just x plus 3 over x minus 2. And we just need to set each of these original denominator factors equal to 0 and solve and say that x cannot equal those, because x cannot equal those. So those are the restrictions. All right, that was this page. Let's keep it going. Let's do some more simplifying. Starting with the first one, the great thing about this one is Most of it's already factored, so we do just have to factor this denominator and this denominator. And the nice thing about multiplying big rational expressions like these is when you multiply fractions, you're basically just multiplying across. So like you can kind of just naturally turn this into one big fraction, like one big numerator and one big denominator. But before we do so, again, let's factor the denominators here. What I'm going to do is probably just leave the numerator where it is, but I'm going to factor these and just write them just below here. So anyway, this denominator can be factored into x, GCF, and x plus 3. So we factor out an x and then x plus 3. Let's get rid of this now. And then this one here, we have x minus 3 and x plus 1. So let's get rid of that. So now what I'm trying to do is treat it as like this is our big fraction now. We have all these terms in the numerator and denominator. So what cancels? We have x plus 3 canceling. Anything else? Very good. X plus 1. Anything else? It's kind of hidden, but do you see it? Very good. X squared over x. We can get rid of one of those x's on top and bottom. So this one goes away, and there's 2 on top, so we just get rid of one of them, leaving us with 1 on top. So up top, what are we left with? We have x minus 2, and we have x minus 2. So that's x minus 2 squared. On bottom, we just have x minus 3. And I think that's all you need. You don't need to identify restrictions for these ones. You're just simplifying. All right, let's keep it going with this last one. This one requires a lot of factoring. And then notice we're dividing this time. So if we're dividing, keep in mind that's the same as multiplying by the reciprocal. So maybe the first step would be to change this division of this fraction to the multiplication of the reciprocal fraction. I'm going to kind of do what I did last time where I just changed the original layout. So let me make sure I got it right. Okay, cool. So we're getting rid of this just to show that what we are doing is this times this. Okay, so now we can just factor numerators and denominators. So starting with this numerator, then that numerator, we have x minus 2, x minus 3, negative 2, negative 3 multiplied to 6, but add to negative 5. I'm going to simultaneously make our entire numerator from factoring this numerator over here. So x minus 6, x minus 2, negative 6, negative 2 multiplied to 12, but add to negative 8. Now, denominators. Starting with the first one, we have x plus 4, x minus 1, multiplying to negative 4, but adding to 3. Then the final denominator, x minus 3, x plus 2. Is that right? Negative 6 and negative 1. Yeah, I think that works. Cool. So we've made our big numerator and big denominator by multiplying across tops and bottoms. And now we simplify. Bye-bye. And, oh, there's nothing else, is there? Cool. Okay. Hopefully I did that right. All right. I think that's it. So whatever we're left with is our answer. So x minus 2, x minus 6, x minus 2, x plus 4, x minus 1, x plus 2. Be embarrassing if I mess something up, but only one thing canceled apparently. So I'm going to leave it like that. That is our simplified answer. Cool. All right, so that was a little bit of simplifying rational expressions. Hope this helps. If you have any questions, let me know.